Hi, so the problem we're going to be looking at today is the 2015 Calc BC free response question number 2, and it reads, at time t is greater than or equal to 0, a particle moving along a curve in the xy plane has a position x of t, y of t with velocity vector v of t equals cosine of t squared, e to the 0.5 times t. And it gives you the initial condition that at t equals 1, the particle is at the point 3, 5. So part A asks, find the x-coordinate of the position of the particle at time t equals 2. And the way we'll attack part A is setting up an integral that takes into account the initial condition. So I prefer the work in the blue. It's the integral from 1 to 2 of the velocity function of x is equal to the position at 2 minus the position at 1. And when you plug that into the calculator, you get negative 0.443. And then you plug in that initial condition that was given in the problem right here, that at t equals 1, x is going to be equal to 3. And you've got a simple addition problem to get where x is at t equals 2. And I'm just going to show you here how to do that integral in the calculator. So you'll go math, scroll down to where it says integral right there. This is on a TI 84 plus. And set the bounds from 1 to 2. And then type in cosine of t squared. I'm just going to use x and d of x, and there's your number, and then you just need to add 3 to get your position. A common mistake on this type of problem is not taking into account the initial condition and just doing the integral from 0 to 2 or something like that, but it's crucial that you take into account the initial condition, because from the integral of velocity is the displacement, so you need the initial position. Now we're going to move on to part B, which reads, for 0 is less than t is less than 1, there is a point on the curve at which the line tangent to the curve has a slope of 2. At what time is the object at that point? So the way we're going to attack that problem is by recognizing that the derivative of the position function is what you're looking for when they ask for slope. So that is those are the functions that are given as velocity. A common mistake would be taking the derivative of the functions given, which is already velocity, and that would be the second derivative. So dy dt over dx dt is equal to dy over dx, which is the slope. So you put in e to the 0.5 t over cosine t squared and set that equal to 2. And I'll show you how to do that on the calculator right now. So the way I do these types of problems to find the t value in a calculator is by graphing. So I've already wrote the functions in to save some time, but there are my two functions. And I just put in y equals 2 and the given left side of the equation. Hit graph and wait a second. And then once it graphs, I'm going to find the point at which the graph of e to the 0.5 t over cosine t squared equals 2. So it's an intersection point. So you're going to hit second, calculus, intersect, first curve, second curve, give a decent guess, and there you go, t equals 0.84. So part C of the problem reads, find the time at which the speed of the particle is 3. So the way we're going to attack this problem is recognizing that speed equals the square root of dx over dt squared plus dy over dt squared. And that is the case because it's the absolute value of the two vectors added together, like the Pythagorean theorem. So when we plug in dx over dt and dy over dt, which is our velocity functions, we get the square root of cosine squared t squared plus e to the t equals 3. And the way you're going to solve this on the calculator is, again, by graphing. So you would go into the y equals section of your calculator, type in the equation from the left side, And so y equals this and y equals 3 into your calculator like that. And then graph it. I've already graphed it to save some time. Find the intersection point, and that is your t value. And there it is, 2.196 if we're rounding. That's the correct answer. The final part of this problem asks us to find the total distance traveled by the particle from time t equals 0 to time t equals 1. And what you have to realize for this part of the problem, which is probably the common mistake, is probably just not understanding the relationship between speed and distance. And you have to recognize that distance is the integral of speed, because speed is already positive. It's the magnitude of velocity, but it's always positive. So what you do to find the distance traveled from t equals 0 to t equals 1 is set up the integral of speed from 0 to 1. And then you'll just plug that into your calculator and come out with an answer. So I'll show you how to do that. So when you're plugging that into your calculator, you'll go math. I just know the shortcut is 9. From 0 to 1, the square root of cosine squared t squared. So I'll add a parentheses there, put x squared, and square the whole thing there, and then add e to the x. And don't forget dx. And your answer is 1.595 if we're rounding, and that is your total distance covered. So that's how you do this FRQ question. Some extra help if you're looking for it. I've posted the links in the description below the video, but here are a few extra problems. Thanks for watching. Hope you found it helpful.